Well, welcome back. In the last class, we were talking about some concentration expressions, and in that we did strength, molarity, we did mole fraction, we did percent by mass. So that today we'll move a bit ahead from percent by mass. But before moving ahead, I would like to tell you one thing that we did percent by mass, and like percent by mass, we have some other concentrations expression also. We call them weight percent by volume. So although this is not there in 11th standards syllabus, but we do have this concentration expression, and it is represented by W by V. This basically represents the concentration of a solute in grams that is present in every 100 milliliter of solution. Next concentration, very similar to this, we have that is volume percent by volume, that is V by V. This concentration expression is basically used where the solute is a liquid like solvent. So it tells us the amount of solute or volume of solute in milliliters that is present in every 100 milliliters of solution. Now the next concentration expression which is there in your syllabus is part per million. So we'll see part per million. This concentration expression is used in extremely dilute case and it is represented by ppm. Well, part per million represents what? It tells you the amount of solute that is present in or part of solute that is present in every 1 million part of solution. When I am saying ppm, we do not have any formula for ppm. It is simply an idea. Like I have got 1 million liters of solution. How many liters of solute I have got in that? That is ppm. I have got 1 million moles of solution. How many moles of solute I have got in that? That is ppm. I have got 1 million kilogram of solution. How many kilogram of solute I have got? That is ppm. I have got 1 million grams of solution. How many grams of solute I have got? That is ppm. So ppm basically tells us the part of solute that are present in every 1 million part of the solution. So this is what ppm is, and you might have come across situation where you would have seen that the weather department, they tells us the quality of air and they tells us the amount of suspended particulates that are present in air, and they basically represent it in ppm. So this is what ppm is, part per million is. In the last class, I promised you one thing, that in today's class I'll be telling you something about normality. So we'll do that, and it's definitely going to take some time. Normality, although it is not there in your syllabus, but in the hidden form it is everywhere. Although it is not, the topic of normality is not given in the textbook, but in the hidden form it is there in the chemistry. It is the spinal part of the chemistry. Reactions, they move according to it. We'll see what normality means. Normality is very similar to molarity. Well, in molarity, we generally say that it's the number of moles of solute that are present in 1 liter of solution. In normality, we say it is the number of gram equivalents of a solute that are present in every 1 liter of solution. So normality is what? It is number of gram equivalents of solute that are present in every 1 liter of solution. So like molarity, we can represent it, that is normality is equal to number of gram equivalent of solute. You know, by writing B, I'm representing solute. Now volume of solution in milliliters. If you divide it by 1000, it will get converted to liters. So like molarity, what I am doing this time, I am bringing the volume to the numerator. So the formula is going to become number of gram equivalent of solute into 1000 upon volume of solution in milliliters. Now the question comes to our mind, what are number of gram equivalents? Number of gram equivalents are very similar to number of moles. Well, if we talk about number of moles, I told you that it is weight upon molar mass. Now when we talk about number of gram equivalents, although it is similar to that but a bit different, it is weight upon equivalent mass. So number of gram equivalent is weight of solute in grams upon equivalent mass of solute into 1000 by volume of solution in milliliters. So this is what normality changes to. Now the question comes to our mind, what is equivalent mass? We have a large number of definitions for equivalent mass. From the perspective of electrochemistry, we can say it is the mass of a substance deposited when a charge of 1 Faraday is passed through it. This is what we did in electro also. What is equivalent mass? We can say it is the molar mass of a substance divided by n factor. What is n factor? I'll tell you, definitely I'm going to tell you that. We have some other definitions also. What is equivalent mass? It is the mass of a substance that reacts or displaces 8 grams of oxygen or 1 gram of hydrogen or 35.5 grams of chlorine. That also we'll see. But here what I am telling you is equivalent mass is molar mass divided by n factor. So normality reduces to weight of solute in gram upon molar mass of solute, and that will be divided by n factor into 1000 by volume of solution in milliliters. Dear students, if you have a look at this formula carefully, you can see that this part of the formula resembles molarity. This is what molarity was. As you can see it over here, we did the formula for molarity. I'll show you. Here you have done this. This is the formula for the molarity. So same formula you are getting. The only thing is it is divided. There it is divided by n factor. So here you can see what I am writing, n factor. If I bring this n factor to the numerator, the formula for normality becomes normality is equal to molarity into n factor. So one formula for normality you are getting this one, that is normality is equal to molarity into n factor. And the second formula which you have got is equivalent mass is equal to molar mass divided by n factor. So this is what normality comes out to be. Now the whole thing comes on to n factor. What is n factor? Molarity I have already taught you. If I teach you what n factor is, you can easily multiply molarity by n factor to get normality. So we'll see what n factor is. If I say n factor is different for different substances. Like if I talk about n factor of an element, the n factor of an element is always equal to its valency. Will not say oxidation state because it changes, but valency that remains constant. For example, if I talk about sodium, this is the element I have got, E for element. We'll see its valency, that valency will become n factor, and we'll see its equivalent mass. So for sodium, the valency is 1, so its n factor is 1. The molar mass of sodium is 23. So if you divide 23 by 1, you will get 23. That means its equivalent mass is also 23. Now if I talk about calcium, the valency of calcium is 2. Its molar mass is 40. If you divide it by 2, you will get 20. That is its equivalent mass. Likewise, if I talk about aluminum, its valency is 3. And in that case, if I write molar mass, that is 27, and I divide it by 3, I'll get 9. That's the equivalent mass. So this is how we calculate equivalent mass of an element. From here, you can easily think about the equivalent mass of carbon, because its molar mass is 12 and its valency is 4. So you can easily calculate its equivalent mass. After elements, the second thing we have is a salt. Well, a salt is always made up of a cation and an anion. So we can say it is the net positive charge on the cation. Net positive charge on the cation. Now suppose I've got, again, I'm writing salt. Then we'll have its positive charge. That will become its n factor. And we'll have its equivalent mass. Suppose I'm talking about sodium chloride. Here you can say that the positive charge on sodium is 1. So its positive charge is 1, its n factor is 1. The molar mass of sodium chloride is 58.5. So its equivalent mass again is 58.5. If I talk about calcium carbonate, in that case the valency of calcium is 2. So in that case I can say its molar mass is 100, so its equivalent mass will be 50. Likewise, if I talk about sodium bicarbonate, here its valency, see the positive charge on sodium is 1, but we have got 2 sodium atoms. That's why we can say the net positive charge is 2. Its molar mass is 106, its valency is 2, so its equivalent mass comes out to be 53. So in case of salts, it's the net positive charge on the cation. Third, we'll see n factor of an acid. The n factor of an acid is always equal to replaceable H positive ions, and that is known as the basicity of the acid. Well, in that case, if we take an acid, we'll see its H positive ion, that will become its n factor, and we'll see its equivalent mass. Now suppose I'm talking about HCl. HCl can donate 1 H positive ion. Its molar mass is 36.5, so its equivalent mass again is 36.5. By 1, that is 36.5. If I talk about H2SO4, well, H2SO4 can donate 2 H positive ions. So its n factor is 2. Its molar mass is 98, and if you divide it by 2, you will get 49. That's the equivalent mass of H2SO4. Likewise, I've got a compound H3PO4. It can donate 3 H positive ions, so its n factor is 3. And its equivalent mass is its molar mass divided by 3. I have another compound, that is H3PO3. Its n factor is 2. And its equivalent mass is molar mass divided by 2. Another compound I've got is H3PO2. Its n factor is 1. Its molar mass divided by 1. That is, its molar mass is its equivalent mass. Now the question comes to our mind that these 3 compounds, that is H3PO4, H3PO3 and H3PO2, they have 3 hydrogens. Then why I am saying that one of them is capable of donating 3 H positive, another one is capable of donating 2 H positive, yet another one is capable of donating only 1 H positive. The first one is triprotic, the second one is diprotic, and the third one is monoprotic. Well, the answer lies in their structure. Let us have a look at the structure of H3PO4. The structure of H3PO4 is like this. You have 3 OH group. The structure of H3PO3 is like this, where you have only 2 OH group. H3PO2 is like this. Here you have only one OH group. Well, the number of H positive ion donated is always equal to the number of OH negative ion. It is only oxygen, that is the second most electronegative element, which is capable of withdrawing electrons and removing hydrogen as H positive ion. So here in this case, you can have this and this H positive ion that will be donated as proton. Here in this case, you will have only two H positive ions that will be donated as protons. Whereas in this, you will have only one H positive ion that will be donated as proton. So H3PO2 is monoprotic. Now a question comes to our mind. What will be the N factor of H3BO3? Again, it seems to be a bit confusing, and many a time a question comes to our mind or an answer comes to our mind that in case we know the structure of this compound, we can easily predict its N factor. Well, in that case, I would like to show you its structure. The structure of boric acid is like this. It is like this. When I draw the structure, the next thing which will come to your mind is that this compound has got 3 OH group. That means it's triprotic, whereas it is not like that. H3BO3 is monoprotic. It donates only one H positive ion. So its equivalent mass is its molar mass divided by 1. When I am saying that it is monoprotic, again a question comes to your mind that how it is monoprotic. It has got 3 OH group, and what I taught you a bit back is that the number of H positive ions which will be donated is always equal to the number of OH group. Now since H3BO3 has got 3 OH group, it should donate 3 protons. Well, in that case, I would like to tell you that H3BO3 is not at all a protic acid. In fact, it's a Lewis acid. If you have a look at this compound, you will see that the octet of boron is not complete. You'll see the boron is forming 3 bonds, one, and in every single bond, you have 2 electrons. So 3 bond means it has got 6 electrons. Its octet is not complete. When you dissolve this compound in water, it will break water molecule into 2 parts, that is H positive and OH negative. It will gain a pair of electron from oxygen, resulting to the formation of a compound like BOH whole thrice single negative. I'm extremely sorry, it is not BOH whole thrice, it is actually BOH whole 4 because 3 OH they were already there. So very correctly we'll write it BOH whole 4 single negative, and it will result in donation of H positive ion from water. This H positive ion, although it is donated by water, but it is considered as a proton because of boric acid. That's why it is considered monoprotic. Now next is the N factor of a base. The N factor of a base is always equal to the number of replaceable OH negative ions, and that is known as the acidity. Like if I talk about sodium hydroxide, it can donate 1 OH group. So it's N factor and its molar mass divided by 1. That is its molar mass is its equivalent mass. Likewise, if I talk about calcium hydroxide, it can donate 2 OH group. That's why its equivalent mass is half of its molar mass. If I talk about aluminum hydroxide, that is AlOH whole thrice, its N factor is 3. So its equivalent mass is 1/3 of its molar mass. So this is how we can calculate equivalent mass of bases. That is always equal to the molar mass divided by the N factor, and the N factor for them is the number of replaceable OH negative ion. The last substance about which we will be talking is an oxidizing and reducing agent. N factor of an oxidizing and reducing agent. N factor of an oxidizing or reducing agent. Well, oxidizing agents are those which have a tendency of gaining electrons from some other elements or compounds. Likewise, reducing agents are those which have a tendency of donating electrons. So n factor of an oxidizing or reducing agent is the number of electrons gained or lost by it. So it is always equal to the number of electrons gained or lost by it. For example, if I give you an example of potassium permanganate in acidic medium, well, potassium permanganate, that is KMnO4, I'm adding some H2SO4 into that. That will combine with H2SO4 and will give me K2SO4 plus MnSO4 plus H2O plus oxygen. So let us balance this equation. I will write 2 because I got 2K. So I will get 2 MnSO4, 2 SO4 and 1 SO4, that is 3 SO4. So you'll have 3 H2O and you'll have 5 moles of oxygen. Well, in the reactant side, if you calculate the oxidation number of manganese, it comes out to be plus 7. Whereas on the product side, it comes out to be plus 2. That means manganese is changing its oxidation state from plus 7 to plus 2. That means manganese is gaining how many electrons? 5 electrons. So in this case, if its molar mass is m, its equivalent mass is m by 5. So this is what its equivalent mass is. I'll give you one more example for this. Suppose I have got potassium dichromate, that is K2Cr2O7 plus H2SO4. It will give me K2SO4 plus Cr2SO4 whole thrice plus H2O plus oxygen. So let us again balance this equation. SO4 total is 4. So I'll write 4 moles of H2SO4. I will get 4 moles of H2O and I will have 3 moles of oxygen. In this case, on the reactant side, if we calculate the oxidation number of chromium, that comes out to be plus 6. Whereas on the product side, it is plus 3. That means chromium is changing its oxidation state from plus 6 to plus 3. That means one of the chromium is gaining how many electrons? 3 electrons. And how many chromiums we have got here is 2. So total number of electrons gained is 6. That's why its equivalent mass is its molar mass divided by 6. Many times students, they get confused that how come in the first example I am taking only 1 manganese, not 2 manganese, although there are 2 manganese, whereas in the second case I am taking 2 chromium. Well, I'll tell you, means many time explanation which is given is like in the first case, if we had to have a look at the number of manganese atoms that are present in 1 mole of KMnO4. 1 mole of KMnO4 has got only 1 manganese, whereas 1 mole of K2Cr27 has got 2 chromium. So we'll consider 2 chromium in case of 1 mole of K2Cr27 and we'll consider 1 Mn in case of 1 mole of KMnO4. Well, after doing this, after considering this n factor, the second thing which comes to our mind is that we are quite comfortable in normality. We know that it's molarity into n factor and by now we know n factor. But when we talk about some competitions and when we talk about some questions of competition, very common questions they are asked. Like I give you one example which becomes very difficult even after studying all this. Suppose a question, I'm giving you a question whereby I say that 2 grams of an unknown metal when burnt in excess of oxygen gives 5 grams of its oxide. In this case, I do not know the formula of the oxide, so I do not know the valency of metal. I do not, in this question, the molar mass of the metal is not given to me, the valency of the metal is also not given to me, and I have been asked the equivalent mass. When such a question comes, the whole knowledge which we have got regarding normality and equivalent mass, it seems to be of no use. Because we know that molar mass divided by n factor will give us equivalent mass, And in this question, neither the molar mass nor the n factor is given to us. Well, such a question is based on the definition of equivalent mass. So we'll see what is the definition, and by after doing that, a lot of things they'll become clear to you. Equivalent mass. What is equivalent mass? Here in this chapter, we'll say that equivalent mass is the mass of a substance. Kindly remember my words. Kindly pay attention toward these. Equivalent mass is the mass of a substance that reacts with or displaces 8 grams of oxygen or 35.5 grams of chlorine or 1 gram of hydrogen. This is what equivalent mass is. So if we have a look at this question becomes very easy for us. 2 grams of metal is combining with oxygen to form 5 grams of metal oxide. 5 grams of metal oxide contains 2 grams of metal. That means 3 grams of oxygen is there. So in this question, we can say that 3 grams of oxygen is reacting with 2 grams of metal. That means 8 grams of oxygen is going to react with 2 by 3 into 8 grams of metal. So this will give you the equivalent mass of the metal. I would like to show you one more thing. Like in this example of KMnO4, we can say, I'll show you how we'll calculate equivalent mass, and it will come out to be this m by 5. In this equation, you can say that if the molar mass of KMnO4 is m, then 2 moles of m is reacting to give you 5 moles of oxygen. You can say that 5 into 16 grams of oxygen is given by 2m grams of KMnO4. So 8 grams of oxygen will be given by 2m upon 5 into 16 into 8. You'll see 8 to the 16 and 2 will get cancelled. Again, you will get m by 5 as the answer. So again, we are getting the same equivalent mass. So this is what you can do. And this is how you can calculate the equivalent mass. So in this class, basically, we have learned about normality. We have learned about the relation between normality and molarity. That is, normality is molarity into n factor. You have learned about the relation between molarity and equivalent mass. That is, equivalent mass is equal to molar mass by n factor. We have learned about the n factor of different substances like salt, element, oxidizing or reducing agent, acids, bases. We have learned the definition of equivalent mass. That is, equivalent mass is the mass that reacts or displaces 8 grams of oxygen or 35.5 grams of chlorine or 1 gram of hydrogen. So this is this topic, since you people were asking for normality, that's why I did this topic. So kindly do this, and in the next class, we'll proceed with some of the part of your school curriculum, that is limiting reagents, stoichiometry. We'll be talking about this equivalent mass also to a larger extent, and we'll do something based on vapor density also. So next class, again, it will be some of the part which is not in the CBSE and some of the part which is there in the CBSE. Today we'll be doing this much only, and again, before ending the session, I would request you people to please subscribe my channel so that you'll get all the notifications. Please do subscribe and please do press the bell icon. Then only you'll get all the notifications and you'll come to know what all videos I'm uploading. Thank you very much. Thanks for joining. Thank you.